Infrastructure limits are now a board-level risk. For much of the past decade, supply chain disruption was treated as a temporary shock, an external condition expected to normalize as markets adjusted. That assumption no longer holds. For C-suite and operations leaders, infrastructure-linked supply constraints are now exerting a direct and lasting influence on capital planning, operational sequencing, and enterprise risk management. Nowhere is this more visible than in the U.S. electric grid, where transformer shortages and interconnection backlogs are no longer abstract system challenges, but material constraints shaping real-world project timelines and operating decisions. From market volatility to structural constraint, recent analysis from the National Infrastructure Advisory Council, NEC, underscores the scale of the challenge. Utilities and developers ordering large power transformers are facing delivery timelines measured in years rather than months, a sharp departure from pre-pandemic norms. According to the NIX June 2024 report, average transformer lead times have expanded from roughly 50 weeks in 2021 to approximately 120 weeks in 2024, with some large units stretching as long as 4 years or more from order to delivery. This shift reflects more than residual pandemic disruption. Electrification across transportation, buildings, data centers, and industrial processes is driving sustained demand growth at the same time aging grid assets require replacement. The result is a tight market where supply constraints persist, even as capital investment accelerates. For executives, this creates a new operating reality. Capital may be approved, demand may be clear, but execution is increasingly limited by infrastructure availability. Operations planning under supply-driven limits. The operational consequences of this mismatch are cascading across sectors. Manufacturing facilities, logistics hubs, healthcare systems, and data-intensive operations are encountering delays not because of internal readiness, but because upstream grid components are unavailable. In many cases, operations teams are being forced to redesign project sequencing around equipment lead times. Extended waits for transformers, switchgear, and other critical components are prompting phased commissioning, temporary on-site generation solutions, and revised load assumptions. These workarounds protect near-term continuity but add cost and complexity that were not part of original business cases. Maintenance strategies are also shifting. Longer replacement timelines are encouraging asset life extension programs, expanded spare inventories, and more conservative reliability planning. What once sat squarely within procurement or engineering functions is now a board-level concern tied directly to uptime resilience and revenue protection. Interconnection backlogs expose systemic risk. The challenge is compounded by interconnection bottlenecks. Analysis from PJM Interconnection, the largest regional transmission organization in the U.S., illustrates how grid constraints are slowing the pace at which new generation and large loads can connect. The volume of projects in interconnection queues now rivals or exceeds existing installed capacity, signaling that grid readiness, not project ambition, is the gating factor for expansion in many regions. While not all queued projects will ultimately be built, the scale of the backlog highlights a structural imbalance between grid infrastructure and economic activity. For operations leaders, this introduces uncertainty into siting decisions, expansion timelines, and long-term growth strategies, particularly for energy-intensive facilities and data-driven operations. Supply chain volatility becomes an operational risk. What distinguishes the current moment is how deeply supply chain volatility has moved into day-to-day operations planning. NIAC's analysis identifies several reinforcing factors. Transformer shortages are emblematic of a broader pattern affecting electrical steel, copper, skilled labor, and specialized manufacturing capacity. For executive teams, this reframes supply chains from cost centers into strategic risk domains. Operational feasibility is increasingly determined by supplier concentration, geographic exposure, and infrastructure dependency rather than internal efficiency alone. Executive implications, from optimization to resilience. At the C-suite level, these constraints are changing how risk is evaluated and discussed. Boards are asking fewer questions about marginal efficiency gains and more about execution durability under constraint. Scenarios that once appeared conservative are being stress-tested against multi-year equipment delays, regulatory lag, and infrastructure bottlenecks. This shift is visible in capital allocation decisions. Investments in backup power, on site generation, and energy flexibility are gaining priority over incremental efficiency improvements. Resilience is no longer a defensive posture, it is becoming a prerequisite for growth. Looking ahead, planning for constraint, not certainty. The NIAC report makes clear that transformer shortages and related grid constraints are unlikely to resolve quickly. Even under aggressive policy and investment scenarios, expanding domestic manufacturing capacity and modernizing grid infrastructure will take years to deliver meaningful relief. For executives and operations leaders, the implication is straightforward but consequential. Planning assumptions must evolve. Organizations that continue to treat infrastructure availability as a given risk delayed execution, stranded capital, and operational fragility. Those that integrate supply-side intelligence directly into planning, design, and risk governance will be better positioned to navigate an era where constraint, not abundance, defines the operating environment. You've been listening to Sustainability Soundbites by Environment and Energy Leader. For partnership opportunities, please reach out to our team.